Okay, let us go to swim bend test. Guys, I hope you practice, I hope you practice. I will be very disappointed when no failure my exam. So upper we're looking at the indirect method of testing EDC machines. Let me change we are looking at an indirect method. Or the swim bend test. Okay, there's a question in exam ebuza get steps. The swim bend test. You must, as I say, you must read the steps. You might not have time to go through all of them, because we are working against time. Okay, this swim bend test, okay, guys, is used to test the efficiency of a large shunt or compound machine. But it is important to understand the energy flow in a DC machine to work with the swim bend test. The energy flow ihamba kanje in a DC machine. The power input, page 38. The power input is equals to, the power output is equals to, is it input? Yes. Power input is equals to power out plus what? What are those three losses? Those three losses are your armature copper loss, shunt copper loss. A1 here, we iron and what? And friction. You'll remember mostly Hopkinson back-to-back test, the iron and friction loss in Balajan. It can be asked in two ways, where we are assuming efficiencies are equal, or we are assuming that the iron and friction loss in the two machines are divided equally. Okay, that was Hopkinson, but here we're going to swim bend test. Okay. How perform this test, okay, guys? You first gonna perform it at no load, and we are going to run it as a motor. We're going to run it as what? When we say we perform an electrical machine at no load, it means the power of that machine is equal to 0 watts at what? No load. Can you see on the board? Yes. Okay. So if you look at there, we have a shunt a shunt motor, a shunt machine that is being ran as a motor. The ammeter is reading the no load current ammeter 1, then ammeter 2 will read the shunt current. Page 38. Shunt current I change again, guys. Remember, shunt current does not change because shunt current is equals to what? V over what? R shunt. Then go when the chinta idon, armature current depending on the load. Okay, so ammeter 3 is measuring the no load armature what? Current, because we are performing a no load test on this DC machine. Okay, now guys up. Formula for calculating, page 39, formula for calculating what? Iron, friction and windage loss at what? So for this test, iron and friction loss in what? No load. Yeah? Okay, we only calculated at what? At no load. And iron and friction loss is a constant what? Loss, eh? It is a what? So if you say at no load, it will be still the same value at what? At full load. Because it's a constant loss. Iron and one, the shunt copper loss. And kumbula must shunt copper loss and one constant loss. The only variable loss is armature copper loss, because the armature current change depending on the load. Okay. So the only variable loss is armature current. So we have a no load armature copper loss and a full load what? Armature copper loss. So that is why again we run at this test at no load, is because we are trying to calculate the no load losses, the no load loss, which is the iron and friction loss. Nah? Okay, the next test, swim bend test on what? On full load, it means the power out now. The power out is no longer equals to what? 0. Okay. This machine is delivering an output. This machine is delivering a what? Output. Okay. If we go to the next page, they are showing us the formula to find what? Iron and what? And friction loss. And remember, we are using this notion that P in is equals to what? P out plus what? 3 losses, of which is 2 of them are copper and armature. So the third one we're going to manipulate for. And then hence this is what iron and friction loss is equals to power in minus these other 2 losses. Why am I putting a 0 here? No power out. Why am I putting a 0? Because when you are finding iron and friction loss, we determine it at what? I'm putting a 0 because power out here was 0. Remember, they took out negative because you only like subtract and up here. They take out negative as non-common fact. Plus the AP loss plus shunt copper loss plus armature copper loss. I'm gonna put armature copper loss at what? No load. That is why I'm putting a dot 0 there. That is how we calculate the iron and what? And friction loss. Then once you get the iron and friction loss, we are able to calculate the efficiency, because as is we are a copper loss, the copper loss, the power are easy to calculate. Shunt loss. Okay, they are easy to what? Calculate. So we are able to calculate the efficiency as follows at any load. You use the formula for the efficiency of the motor. For a motor, take 1 minus what? 3 losses. Over what? V I L. So the current, guys, listen here. The current I2, it is the current we are required to calculate the efficiency at. If let's say this is about efficiency at a load of 50 amps, this is the current that I will put there. If we itibala at 30% of, let's say this current is what? Full. It's full what? Load. But then if you want to buy like efficiency at 80% of what? Also, we IL at 80% of what? Full load. Okay, banu 80% ka 50. Let's say 30 amps as example. That means now we are calculating efficiency at what? 80% of full load current. Okay. Hence, into OIL is the current that we are required to calculate the efficiency at. IL is the current that we are required to calculate the efficiency at. Then let us look at for each generator. There is still the formula. The efficiency generator is what? VIL2. Because alone, remember my question, I think calculate the efficiency of the generator or immunity. Plus the 3 what? Losses. I even have more videos on this topic on YouTube. Then we are going to talk about maximum efficiency. Okay. Question nothing. Find the armature current for maximum what? Efficiency. For maximum efficiency, variable losses are equal to constant what? Of which is game of variable loss in other than it is 3 as losses so in how much of a loss say as I'm gonna say I what? A 3 squared R A equals to says the constant loss, shunt copper loss and plus iron and what? Friction loss. So you equate like this. The question you wanna integrate similarly the armature current to obtain what? Maximum what? Efficiency. Integrate the question it is similarly the armature current to get what? Maximum what? Efficiency. Okay, and of which is what I want to correct now from the textbook. I've been attended any workshop, but I wanted to ask phaa workshop uba ithini into yabo, because into eyenzekayo your textbooks and the memo phofu ke leza memo zibhalwe ngumntu na, not from the department. Memo ivela from the department iba nestamp na. I see that power memos, they consider what? Amateur copper loss at what? No load. Yeah, but as a result, the mobile losses see? 4. Amateur copper loss at no load, amateur copper load is full load, then it was a 4. Yabo? Kowe memo pa. Yabo? Our textbook, they are saying to us, because in only amateur copper loss at no load is what? It's very what? Small. We cannot neglect. Yeah, that is why I take 3 board. Yeah, so it's up to whether you go with this one or go with this one, because says revised curriculum party, you would find that the answer they differ slightly. The answers will just differ what? Slightly. Okay. So I think it's best we can consider the amateur copper loss at no load. Hence I'm saying I'm not sure, I haven't attended any party. When say AP, your answer will still be what? I believe it should be what? Correct. Okay. Let us look at for example, the following example. Then we start with Inoni transformers, and as I've said, I mentioned I don't want to touch any textbook next week. I want to touch question papers. I will try to print as much as I can question papers. Batipana a shunt motor running at light. Light means no load. A shunt wound motor running light at money 700 revs per minute, that is page 41, takes 3.6 amps from a what? 500 volt supply. The field resistance is 250. And notice, guys, I don't want you to confuse this topic. Huh? Once it question it taking a shunt motor, a question that could be speed control, or it can be swim pen what test. Now so one up because of funny efficiency and sometimes I was combine swim pen test and but game of low speed control bazothetha yintoni shunt. But if you take a series, there's no swim pen test with series. That means the speed control car I control now. As I'm going to bayakwazi combine this topic na speed control. I will tell you shunt. Okay, but with a locked armature, 24 volts is required to pass 48 amps, okay, through the armature. Calculate the efficiency of the motor when it runs at 50 amps. So we have one upon efficiency at what? 50 amps. when it draws 50 amps from the supply. UB wants us to find the armature current drawn by the motor when it works at what? Then UC wants us to find the maximum what? Efficiency, then yabona. UD wants us to find the speed of the motor when running at what? Yeah, is combined with the speed control. So if I'm gonna read each sentence and interpret it, a shunt wound motor running light at 750 rev per minute. So N1 lower. Okay, as I'm saying, this top bag was a combined speed control. Then but it takes 3.6 amps from a what? Supply. So IL0 lower no load what? Current. IL what? 0 Okay. Ile ndizoyisebenzisa to find no load armature what? Current. But again, the field resistance is 250 ohms. Okay, the field resistance is what? 250 ohms, meaning is what? Current. Because I have the voltage, I have the field resistance. But again, with a locked armature, 24 volts is required to pass 48 amps. Guys, if the armature is what? Armature is locked. Don't irritate is speed semoto mbani bajo mosine baitin inga move it is what? Locked. And how do we calculate armature current? Using Ohm's law. V minus what? E over what? RA. So if armature is locked, that means it is what? Not moving. And if it is not moving, it means OE is equal to 0. And but if the armature is locked, 24 volts meaning UD 24 is required to pass 48 what? 48 amps. Okay, so that is what we use to find the what? Armature what? Resistance, because we would want to find the armature resistance because we want to know this is what in armature what? Copper losses. Okay. But you find the efficiency of what? The motor. And I've said you always when it draws 50 amps from the supply, it's in the formula for the efficiency of the motor. It's 1 minus 3 losses over 3 IL 2 times 100. Okay, so it means for me to find the efficiency, I need to know what are these what? 3 losses. Okay, in order to find these what? 3 losses, I first have to find let's say iron and what? Friction loss, because this is in which is equals to bani power in. What is power in? Power in will be I and no what? Load. And minus open brackets, power out is still money 0. Then plus shunt copper loss. The shunt copper loss, okay, guys, I see there are two formulas. You can use this one, VI shunt, or you can use what? I shunt what? Squared R what? Shunt. Anyone said correct, yeah, okay. And normally they use this one was quicker, or something. So B I shunt and then they pay you loss that day. Amateur copper loss at what? Load. Guys, amateur copper loss again at no load. We are in 7 sir. How about the iron what? The only time the textbook they ignore it is when they are calculating the what? Efficiency. Hence multi-3 part efficiency. But iron and friction loss or yeah. The only time they ignore is when they are calculating what? The efficiency. Okay. So when uzoyama ngezitep guys and yes step the way yabo and ithanda ubale ngehlobo ithanda uyibhale phansi uthi I shunt copper loss uyibale so usebenzise la formula sebenzise ntoni ecaleni uyibhale mhlawumbe ufumane yabona nabo benze njalo ufumane bani 1000 what once yabo then i-amateur copper loss at what at no load uyibale nayo yabo which is gonna be what is the armature current at what? No load. Armature current at no load is over money. Remember, this is a shunt, ne? This is over IL what? No load. And minus what? I what? I shunt. What I shunt again? Bombali even go banana shunt copper loss. So I shunt one would be over what? You're given not R shunt. Yeah, then I no load man. Take move 3,6. Okay. Then of money on amateur current at no load. Once you get amateur current at no load, it's easy to get what? The amateur what? Copper loss. Now you can use what? This formula now. Nah? You just have to ask yourself what is the input power, and the input power will be what? In this case 500. What is the no load current? Times what? 3, what? 6. Then you subtract it by shunt copper loss. You subtract amateur copper loss at what? No load. Money iron and what? Unazo ke ngoku losses zakho zi-3. And we can find the efficiency. Uzothi sebenzisa the formula. The formula uzofaka i-shunt copper loss. Okay. As kabikho i-3 ne? See, the 2 ne? Eshotayo amateur copper loss at what? Full load. The amateur copper loss at full load also 7 kasibale amateur current sizosebenzisa labani la 50 what 50 amps na 50 minus what I what shunt ibone ngobe sebebala at no load amateur current besebenzisa the no load current ana apha yona sifuna efficiency at 50 what amps. So we're gonna say what is the armature current at what? At full load, né? Or we say what is the armature current when the load current is what? 50 amps. So then we can calculate the armature copper loss at what? At load, né? Then we can calculate the is over IA squared RA. Then you get your what? Third loss, your armature copper loss at what? At full load. Anna? Okay, then you can use what? This what? Formula, né? I'm saying the textbook is only saying 3. It's using what? 3. I buy the 80. The amateur copper loss at what? No, you can even add it. Yeah, it's very 4. We see that the answers game was all fun and this is memos, question papers. Scatter red light. Okay. The next question wants us to find the current, the armature current drawn by the motor when it what? Works at what? Full load, maximum what? Efficiency. So you're gonna say IA squared then would RA somebody armature resistance. 0.5 times equals to so that's the constant loss, shunt copper loss, iron and what? Friction. So a shunt copper loss will be 1,000 plus iron and friction doing money. What? 798 what? 798.72 next.
8.72.
This was on
72.
Okay. Then you find the armature current. What squared pi? Squared. So once you divide, then after you put a what? A square root. Guys, again, if you don't practice this topic, yes, when parent test, it's gonna confuse you. You can easily what? Confuse. That is why you must practice. What was these are questions and techniques. If you go, even myself can deliver this calculation. What is the child? But then I'm just another now. Was those calculations if you take was practice repeatedly. Practice them repeatedly. Kamnandi was practice and actually over then you'll be done. We're going to take a calculation short circuit test, open circuit test, power voltage regulation, alternate. I'm sure answer in a clue. Or can take a T method. If that is why I'm saying, when I am teaching you, Okwenu is just to go and practice the stuff. Nobuhleli phambi kwe-TV wenza ntoni? Kamnandi calculation. that is how we calculate, you know, the armature current at maximum efficiency. We are saying variable losses are equals to the what? Constant losses, of which is the constant losses A2. The variable loss A1, armature copper loss. Once we get the what? It basically the maximum what? But basically the maximum efficiency of the what? There are two things that we have to do, Gembo. We have to calculate what is the armature copper loss if besifumene bani I3 pa?
59.
Armature current ethu ngubani?
The one that we got, yeah, it's 59,979.
97 what? 9. If the armature armature current at maximum efficiency of mana,
59.
so that's when efficiency at maximum, your that's when efficiency at maximum efficiency. We're gonna say what is the armature copper loss for the current in 59, because that is the armature current at what?
Maximum efficiency.
At maximum efficiency. So what is the armature copper loss at what? Maximum efficiency, which is gonna be what? IA3 squared R by A. And then remember, you cannot use ubani IL. You cannot use that 50 or IL2 though, because the armature current has changed. It means no IL was what? Changed. So IL motor or IA3 is gonna be IL what? 3 minus what? You don't change your I shunt. And okay. Meaning can for no IL3. Meaning transpose bani I shunt. So hence we go to IL3 is equals to IA3 plus what? I what? Shunt. This is the current that I'm going to use when I'm calculating the what? The efficiency. With the armature copper loss also calculated at what? Maximum current at a current for at a current of the armature current of the maximum what? Efficiency. Yeah, you guys get the idea, na? Then it can go basibale what? The speed of the what? Motor when working at what? Maximum efficiency. Remember speed city E1 over what? E2 is equal to what? If I equate one flux, we use none shunt current. Shunt 1, I shunt 1 and 1 over I shunt what? 2 and what? Obviously, so I shunt they will cancel because shunt current I change in as a damage of our shunt fields what? Resistance. So how do we calculate E1? Well, E1 is over by OV minus IA by 1 R AC. IA1 ila current ibala ngantoni? No load, na? Ana? And it be speed soqala ibe 750 by it takes a current of bani 3,6. So IA1 is over IL wala is over 3,6 minus I bani I shunt. Then you get bani E bani E1. Then E2 gonna be V minus IA2 RAC. And then, how do we find IA2? We say, what is the max? In fact, I was supposed to say IA1 3 because my phone is speed at what? Maximum what? Efficiency. That is why I'm saying IA what? 3. If you know at what? I know at where I know at Bani 50 amps. If you know at 50 amps, this is about la amateur current kaban. IE at what? I low current to IE at what? 50 amps. But because my phone speed at what? Maximum efficiency, I use the armature current for maximum efficiency to find one for E2. Once I get E2, then I can find the speed at what? Maximum efficiency.